Hello guys, my name is Desmond and I welcome you to my YouTube channel. Ladies and gentlemen, as you can see, today we'll be looking at Physical Sciences, Paper 1, the chapter for Work, Energy and Power. So guys, please do allow me to say it's very much important that I say it's very much important because, ladies and gentlemen, what I'm about to say, it's massively important, okay? So a day without learning something new, it's a day wasted. By so saying, I would encourage each of you to make sure that by the end of each and every question, or by the end of the whole of this question, please do make sure that you learn something new. Okay, so ladies and gentlemen, without any waste of time, as you can see, we're given a statement for question 5, and also you are advised to start on a new page. Okay, so what I'm going to do is to quickly read through the statement. From there, what we're going to do is just to quickly analyze the given diagram, go through each and every question, solve the question, and most importantly, I'm going to show you where you score your marks. Okay, so ladies and gentlemen, let's not waste any more time. So as you can see, question number 5, I'm going to read through the statement. So a rescue helicopter is stationary, in brackets, hovers above a soldier. The soldier of mass 80 kg is lifted vertically upwards through a height of 20 meters by a cable at a constant speed of 4 meters per second. The tension in the cable is 960 Newton. Assume that there is no sideways motion during the lift. Air friction is not to be ignored. Air friction is not to be ignored. Ladies and gentlemen, it's very much important that you fully understand exactly what is going on there. And most importantly, it's very much important that you fully understand what the given statement instructs you to do, what to note and what not to note, and most importantly, what to ignore and what not to ignore. So, ladies and gentlemen, before I start with the interpretation of that given statement that I've just read, I would like to just indicate that this lesson is suitable for grade 11s and grade 12. And again, if you're upgrading this subject, you're also welcome to watch this lesson, okay? And I hope you will enjoy this lesson. So, ladies and gentlemen, as you can see, I've tried to draw by hand this diagram. Remember guys, at all times, it's not by intention to make it perfect, but what matters the most, it's for it to look more or less the same, and most importantly, have those values in place over there. Okay, so guys, for the last time, I'll just read through as I explained. So ladies and gentlemen, we've got a rescue helicopter which is stationary above a soldier. Okay, so that means this helicopter that you see, ladies and gentlemen, it's not moving in any direction. It's not moving forward or to the left. It's not moving to the right. It's not moving upwards. It's not moving downwards, but it's stationary at that point. Okay, obviously it's hovering because it's in the middle of the air. Okay, so ladies and gentlemen, what happens is you've got a soldier of 80 kg. Okay, very much important, ladies and gentlemen, that you notice on that sentence you're actually given the mass of the soldier. And most importantly, ladies and gentlemen, in physical sciences we measure the mass in kilograms. Okay, So just in case if that mass was given in grams, then that means you will have to convert it to kilograms. And obviously when you convert from grams to kilograms, you divide by 1,000. Remember, ladies and gentlemen, kg, it's the mass or the unit in which we measure the mass in physical sciences. Okay, and again, kilo means 1,000. Very, very much important, ladies and gentlemen. So they are saying a soldier of mass 80 kg is lifted vertically upwards through a height of 80 meters by a cable at a constant speed of 4 meters per second. Okay, very, very much important, ladies and gentlemen. I'm not really sure if I should add that information there, because as you can see, we're also given the speed at which that cable is moving. Okay, and most importantly, guys, please do take note of the letters used on the statements. Okay, they've just said cable at a constant speed in capital letters. Very, very much important, ladies and gentlemen, in capital letters. Okay, so it gives you it serves as a hint that somewhere in your questions you might need to refer back to that statement, and what you need could be that constant speed in capital letters. So my advice to you guys, every letter is very, very much important, and the manner in which those letters are presented in the statement, they should be telling you something. Okay, so everything is written in small letters, but that part is written in capital letters. So just make sure that you you stay with me until the end of this lesson, because I need to show you exactly why that is important, and again why it was written in capital letters. Okay, so ladies and gentlemen, I assume you are able to see clearly. So just to remind you guys, if you are not able to see exactly what I'm reading, or if on the screen of your phone, tablet, or computer, or whatever that you're using, it could be laptop or whatever it is, on your phone, I think on the top right corner, you've got some 3 dots there. If you can just click there and click on quality, down there you click on advanced, and then you maximize the quality. I'm not sure if it's 480p or 380p, but as soon as you click on that, you should be able to clearly see each and every letter on my tablet. But otherwise, if you're not able to see, remember I post these question papers on my Telegram channel, so you can quickly access this question paper. Okay, but for now, I need you guys to just pay full attention. You just need your calculator and a glass of water. No need to write anything as I write, because I'm going to make this lesson available as soon as we are done with this lesson. Okay, so ladies and gentlemen, very, very much important that you understand, and again you see what I'm talking about. So now you've got this guy, which is a soldier of mass 80 kg. Okay, so now we've got this cable which is pulling upwards at a constant speed of 4 meters per second, and again the tension in the cable is 960 newtons. Okay, so guys, can I just add there to say that cable, it's moving at a constant speed of 4 meters per second. Okay, ladies and gentlemen, just to give you a hint, if it's moving at a constant speed of 4 meters per second, so that means its initial velocity and its final velocity will be the same. Okay, very, very much important, ladies and gentlemen. So just in case if you need to solve or answer a particular question, and you get to a stage where you realize the formula that you must use has got initial velocity and final velocity, then because it was indicated that the cable is moving at a constant velocity or at a constant speed, then it means its initial and final velocity is the same. Very, very much important, ladies and gentlemen. Okay, so now the tension in the cable I've just explained is also given there. It's 960. Okay, so I'm getting to a part where I'm interested in. So they're saying assume that there is no sideways motion during the lifting. Okay, very, very much important, ladies and gentlemen. Remember, assuming that this is that aeroplane, ladies and gentlemen, this is that aeroplane and this is that cable. Okay, if this is a cable, ladies and gentlemen, for example, let's say it's a steel. Let's just say it's a steel. Okay, so it's just vertically moving upwards, unlike if it was let's say a rope. Okay, you know, a rope, it can be bending somehow as a result of a wind. And again, if this aeroplane, it's not stationary at one point, maybe slightly moving sideways and again slightly moving up and down, that's when you can have a a rope. This is that person, the soldier. That's when you can have a rope moving sideways. Okay, but in this case they are saying this is stationary at one point, not moving sideways, not moving up and down. The only thing which is moving is just that cable. Okay, and the tension is 960 Newton. So, ladies and gentlemen, that means there's only one upward movement. Okay, so that cable is not in any way moving sideways. Okay, very, very much important, ladies and gentlemen. If it was moving sideways, then it was going to have an impact in terms of the forces as a result of it's moving sideways. Okay, so what could possibly make that a cable or a rope to move sideways? It's wind, ladies and gentlemen. If there's a strong wind, then it could possibly move sideways. But the statement says assume that there is no sideways motion during the lift. Okay, I assume you fully understand that part, ladies and gentlemen. So again, they say air friction is not to be ignored. Very, very much important, ladies and gentlemen. Please read this statement in full. I know in most of the questions they would say air friction to be ignored. Okay, but in this case they say air friction is not to be ignored. Okay, this is very, very much important, ladies and gentlemen. It's massively important. That means as this soldier is being lifted upwards, there is a friction as a result of air. Not sure if you understand, ladies and gentlemen. There's a friction as a result of air. Okay, I assume someone already understands that there is a force of friction as a result of air. Okay, so ladies and gentlemen, I'm not really sure if we are all ready to now start tackling these questions. I assume the moment you see a diagram similar to this one, you won't be worried, you won't panic, you'll just have a look at what is given. And I can tell you, ladies and gentlemen, this statement and the diagram, it's actually there to help you to write or to draw the correct free body diagram. Because once you get the free body diagram correct, I can tell you, ladies and gentlemen, your formula is going to be correct, your substitution should be correct. In that way, you will be able to find the correct answers, and in that way you will be able to score maximum marks. Okay, so ladies and gentlemen, I'm just going to read through the first question, and the question says, state the work energy theorem in words. And this question, it's allocated 2 marks. Okay, I'm sure most of you already know the answer because you've been reading, you've been studying a lot, you've read multiple books where they've stated the work energy theorem in words. So I'm just going to quickly state it so that you are able to then compare. Okay, so this question is allocated 2 marks, ladies and gentlemen. So I'm just going to wipe all of this, and then from there we'll start with our very first question, which is question 5.1. Okay, so ladies and gentlemen, normally in physical sciences, when they request you to state either the theorem, they could be saying define whatever that it is. Ladies and gentlemen, what matters the most is that you are able to know the chapter that you are dealing with. Okay, so some chapters, if you can just check the formula sheet, they will guide you in terms of how in terms of how to define or to state theorems, so it's very much important that you know the chapter that you're dealing with, and again, the formulas associated to that particular chapter in the formula sheet. Okay, you remember, ladies and gentlemen, we've got a formula which says work net is equals to change in K, or delta K. Okay, which we know delta K is actually it refers to the kinetic energy. Okay, so ladies and gentlemen, for me, I know I'm dealing with this chapter, okay, of work energy and power. So I can just go to the formula sheet and look for this formula and state the theorem while being guided by this formula. Okay, which means the net work done on an object. Ladies and gentlemen, I've just stated that part. Very, very much important, ladies and gentlemen. The net work done on an object, in this case, which could be a soldier, it's equals to the change in kinetic energy of the object. Ladies and gentlemen, is equals to, okay, it's equals to the change. Remember, this is the change, ladies and gentlemen. In Greek, it's called delta. Okay, in English, is change. Okay, so it's equals to the change in kinetic energy. We know K refers to kinetic energy, ladies and gentlemen. Okay, kinetic energy of the object. Okay, so that's what I'm saying, ladies and gentlemen. In physical sciences, you just need to know the chapter that you're dealing with. You go to the formula sheet, you check the formula, and then from there, you just use the formula to do whatever the question wants you to do. Okay, so I'll just write it down, but for you to know of the trick in this question, or what is it? I'm not actually I don't think calling it a trick, it's a suitable word, but instead, let me say the advice is that as soon as you're given a question where they want you to give a definition, to describe, or to state the theorems in words, this is where you need to know the chapter that you're dealing with. Go to your formula sheet, look for the relevant formula, write it down, and use it to give a description. Okay, so that means an answer to the question is, we can just say the net work done on an object. Okay, so ladies and gentlemen, it's very much important that you indicate that the work done on an object, you cannot just say the work done is equals to the kinetic energy. Okay, so you need to state it in full, in full words, so that it serves as a good indication that you come from good hands. Okay, so the net work done on an object is equal to the change in kinetic energy of the object. Okay, very, very much important, ladies and gentlemen. Remember, this question is allocated 2 marks. Ladies and gentlemen, I'm hoping you're very much happy with what I've just taught you, that you can actually use the formula to state the theorem. This is the net work energy done on an object. Okay, this is equals to the change in kinetic energy of the object. Very easy and straightforward. So by just stating that, it gives you 2 marks. Okay, very, very much important, ladies and gentlemen. Remember, the other one may decide to state the theorem in a different way. Okay, one may say the work done on an object by a net resultant force is equals to the change in the object's kinetic energy. Okay, so it's just a matter of you choosing the one that you feel like it's easy to state, the one that you feel like you won't forget. You can just make use of that definition to answer related questions. Okay, so ladies and gentlemen, I'm not sure if, let me just write it, because in that way it gives you multiple choice in terms of choosing which definition to use as an answer. Okay, so that means the work done on an object by a net resultant force is equal to a change in the object's kinetic energy. Okay, very, very much important, ladies and gentlemen. By so saying, this is how they give you your 2 marks. Okay, remember guys, if you want to have these definitions on record, you can just listen to what I was saying. Don't necessarily need to try and read my handwriting. Okay, it's not that much horrible, but I assume you're able to hear clearly what I was saying. Okay, so ladies and gentlemen, let's now move to the second question, which is question 5.2. Okay, very, very much important, ladies and gentlemen, that you fully understand question 5.1. So now question 5.2 says, draw a labeled free body diagram showing all the forces acting on the soldier while being lifted upwards. Very, very much important, ladies and gentlemen, that you understand the question. They want you to draw a free body diagram, okay, showing all the forces, ladies and gentlemen, all the forces acting on the soldier while being lifted upwards. Okay, so guys, I assume you fully know that you just make a dot there. Okay, so what's going to guide you in terms of how to draw a free body diagram? It's firstly what you see on the diagram, and secondly, what's going to guide you, it's what is in the statement. Okay, very, very much important, ladies and gentlemen. So it's very much important that we firstly start with the obvious forces that we can see on the diagram. Okay, so obviously we can see there's a force applied by the tension. Okay, I assume everyone is able to see that. Then remember, ladies and gentlemen, they set a labeled free body diagram. Okay, so you can just say force by tension, or otherwise one can say force applied. Okay, doesn't really matter whether you say force by tension, or otherwise you can just say tension. It's a force. Okay, so you will choose which one is suitable. Ladies and gentlemen, we know at all times we always have force of gravity. Okay, we always have force of gravity. Very, very much important, ladies and gentlemen. Otherwise, you can just say weight. Okay, because that soldier has got a weight. Ladies and gentlemen, what is represented by this dot? Guys, at all times when they say draw a free body diagram, is because they know not everyone will be able to draw that soldier. Okay, so it's not a chapter for arts and culture where they're interested in seeing you on how you draw. Okay, so they just want you to represent that soldier by making a dot over there. Okay, so that dot actually represents any object which is experiencing forces. Okay, so ladies and gentlemen, remember guys, especially when it comes to this question where they want you to draw the free body diagram, always take into consideration the marks allocated to that question. Okay, as you can see, this question is allocated 3 marks. Okay, very, very much important, ladies and gentlemen. 3 marks. Okay, so guys, it's in most cases where each force drawn is allocated a mark. Okay, so obviously, as you can see, you already have 2 forces drawn on that object. Okay, so you now need the third force. Okay, where do you get that third force? Remember, by just looking at that diagram, you can see you've got a force as a result of that tension, as a result of that cable, which is referred to as a force applied. Okay, and again, there's a gravitational force, or the weight, which is always there. So guys, do we have any frictional force or not? Very, very much important, ladies and gentlemen, that we are able to tell if we've got a frictional force or not. Remember, this is the force that you get from a statement. A friction is not to be ignored. Very, very much important, ladies and gentlemen. A friction is not to be ignored. Okay, in which direction is the air friction acting, ladies and gentlemen? Is it acting in the upward or the downward direction relative to that soldier? Obviously, the soldier is going up, and we know friction is always opposing the direction of the movement. Okay, so that object is moving upwards. That means frictional force will be opposing that soldier. Then you label it, ladies and gentlemen. Very, very much important. You label it. You can just say force of friction. Others, they just use a small letter F. Then we know it represents a frictional force. Okay, ladies and gentlemen, this is how you easily score your 3 marks. Okay, so this is how we mark your papers at Marking Center, ladies and gentlemen. We check if you have drawn let me just do this. If you have drawn your free body diagram and used the arrows. Okay, this is what we check, ladies and gentlemen. Did you use the arrows? Very, very much important, because if you just do this, okay, we don't know in which direction these forces are acting. Maybe they are exerting towards that object, or maybe they are acting in those directions. So that's why it's very, very much important that you make use of the arrows to indicate the direction in which the force it's being applied. Very, very much important, ladies and gentlemen. And again, guys, it has to be labeled, okay? Your forces or your arrows or your lines has to be labeled. That's why they say a labeled free body diagram, okay? Do not just leave it like this, but make sure that you label it. So you normally have force applied, you have force of gravity, you have force of friction, and you might also have, just like there, actually tension and force applied. Sometimes they just choose to use tension. In some questions it could be force applied, okay? Very, very much important, ladies and gentlemen, that you are aware of those type of forces. So I assume we are all on the same page on this question, ladies and gentlemen. I assume all of you are confident, and if this question comes, I'm 100% sure that you guys, you won't disappoint. And again, I assume you will be able to fully answer the question and score maximum marks, okay? So ladies and gentlemen, can we now move to the next question? I assume everyone understood exactly what we were doing there. So now I'll just prepare for the next question. Okay, so ladies and gentlemen, very, very much important that you fully understand what I'm doing here. So now let's try to move to the next question. So this is just opportunity where you can just quickly have a glass of water, ladies and gentlemen. So now we're moving to 5.3. So ladies and gentlemen, question 5.3 says write down the name of a non-contact force that acts on the soldier during the upward lift. Very, very much important, ladies and gentlemen, that you understand the key word in that question. Okay, write down the name of a non-contact force. Ladies and gentlemen, it's very much important that you fully understand exactly what the question wants you to write, okay? So at this stage, we understand they want us to write the force, okay? So that means whatever that we write, ladies and gentlemen, we're not writing anything related to mass, we're not writing anything related to time, we're not writing anything related to speed or velocity, we're not writing anything related to displacement or distance. Why? It's because all of those are not forces. So ladies and gentlemen, they have specified the type of force that we must write down, okay? And they say it's a non-contact force, which means if we've got a non-contact force, then it means there's also a contact force. Very, very much important, ladies and gentlemen. You use this type of information not only to just answer the question, but also for your learning, ladies and gentlemen. So you don't only study by reading what is in the textbook. You don't only study by practicing using the questions in the textbook. You don't only study by relying on the information that your mentor, educator, tutor, or whoever provides you. But most importantly, ladies and gentlemen, most importantly, I've discovered this at an early stage, and I was so grateful that I did discover at an early age that the most relevant information is provided in the question papers. And again, making as many mistakes as possible makes you to learn the value of making a mistake. You learn the value in each and every mistake, and again, you will never get worried in an exam or in a test when you feel like you're about to make a mistake, because you will always find a way to recover from that mistake. Okay, so ladies and gentlemen, getting back to our question, they're saying write down the name of a non-contact force that acts on the soldier during the upward lift. Very, very much important, ladies and gentlemen, that you give this type of questions your full attention. Okay, so remember guys, this is that soldier. Okay, this is that soldier. Very, very much important, ladies and gentlemen. So this soldier is being pulled upward by that cable. So obviously there's a contact between that force of tension and the soldier. Okay, that's what we see there, isn't it? So there's that force, ladies and gentlemen. There's that force which is not in contact with that object. Okay, I know each of you knows that force, ladies and gentlemen. Obviously it's force of gravity. Okay, but please do write down the name. Do not just write it in that way. Just say force of gravity. Okay, this is the name of the non-contact force that is acting on that soldier during the upward lift. Okay, again, one may say gravitational force. Very, very much important, ladies and gentlemen. Okay, so you can either say force of gravity or gravitational force. You will still get a mark. Okay, so guys, can we just make use of this opportunity to just try and explore all the contact forces? Okay, so obviously, ladies and gentlemen, if we've got a steep at a particular angle there, and we've got an object there. So let's say we've got a force being applied there. Okay, so this is one of the contact forces. Okay, because this force, it could be a string or whatever that it is which is pulling this object. Okay, so that string will be in contact with that object. So that means force which is being applied, it's a contact force. Again, ladies and gentlemen, we may also have a frictional force. Okay, force of friction. Okay, so force of friction, ladies and gentlemen, comes as a result of that object being in contact with the surface. Okay, so I just want you to understand the difference between the non-contact force and the contact forces. Okay, so ladies and gentlemen, that means gravitational force, in that case, it's not in contact with the object, it's a non-contact force. Okay, so I hope I've opened your eyes a little bit, but obviously I know some of you already knew about this, but it doesn't really matter, ladies and gentlemen. Remember, we're just trying to accommodate those who feel like they are left behind and they need this extra information, because you'll never know, ladies and gentlemen, based on how the question is asked, you might need this information that at the moment you might feel like you already know. Okay, so it's best to appreciate all the information that you're being given, regardless of who's giving you that information. Okay, so ladies and gentlemen, let's now move to question 5.4. Okay, so ladies and gentlemen, they're saying use the work energy theorem to calculate the work done on the soldier by friction after moving through the height of 20 meters. And this question is allocated 5 marks. Okay, I hope you're able to see, ladies and gentlemen. So, very, very much important, guys. They want you to use the work energy theorem, okay? So, do not use anything else other than work energy theorem. Very, very much important, ladies and gentlemen. Use this theorem to calculate the work done on the object or on the soldier by friction after moving through the height of 20 meters. So, ladies and gentlemen, they want you to use that theorem, okay, to calculate the work done on the soldier by friction. This is what the question wants you to calculate. So that means you are actually calculating the force as a result of friction. But most importantly, ladies and gentlemen, at all times, try, to visualize exactly what the question wants you to calculate. Remember, on that 5.2, we drew a labeled free body diagram, okay? So it's in most cases where you need to refer back to that diagram that you drew, okay? So, ladies and gentlemen, please do allow me to quickly redraw that free body diagram because it serves as a guide for us in order to be able to visualize exactly what they want us to calculate. So this is that force by tension, and we've got a force of gravity, and again we've got force by friction. Okay, can you see, ladies and gentlemen? So that means these are all the forces acting on that object. Okay, so now the question wants us to use the work energy theorem to calculate the work done on the object or on the soldier by friction after moving through the height of 20 meters. So, ladies and gentlemen, this is one of those questions where you might need to apply your full understanding, ladies and gentlemen. Let's just quickly try to check something. Let me see. Use the work energy theorem to calculate the work done on the soldier by friction after moving through a height of 20 meters. So what I'm actually trying to check, ladies and gentlemen, is to check if they want us to calculate the work or the force. Remember, these are two different things, ladies and gentlemen. There is work done as a result of a particular force. So this is a free body labeled diagram of the forces acting on that object. So because of these different forces, ladies and gentlemen, they are making some work on that soldier. Okay, so that means this question actually wants us to calculate the work as a result of the frictional force. Not sure if you understand, ladies and gentlemen. I'm not really sure if you understand, but the best way to make you guys understand is by saying our final answer should be in joules and not in newtons. I hope, ladies and gentlemen, this opens your eyes and you fully understand what I'm trying to say. Because at first I read that question as if the question wants us to calculate the force. Okay, so it's very much important, ladies and gentlemen, that you especially when you're practicing, I always say there's a value in every mistake. And I try by all means to be the one making those mistakes on your behalf. But most importantly, please do make sure that as soon as I've done this question, you go through my Telegram channel to browse through all the question papers that are posted there. And then as soon as you identify a question which is similar to this one, then you give it a try and make those mistakes. I've got a WhatsApp number where you can just confirm where you've gone wrong by just sending a photo of your calculations. Then in that way, I'll be able to notice that, okay, this is what your approach looks like. This is what you're trying to do. In that way, I'll be able to guide you in terms of how to go about that question the right way. And again, I'm going to try and find out which mistakes you made, how you made those mistakes. Then we discuss those mistakes so that you are aware of the types of mistakes associated with that particular chapter. In that way, ladies and gentlemen, if you make those mistakes at an early stage, I can tell you, I can promise you now that in the exam room, you won't make those mistakes. Even if you can do those mistakes, you will still be able to recover from those mistakes. So, ladies and gentlemen, I hope we are now on the same page. The question wants us to calculate the work, which is measured in joules, the work done on the soldier by friction after moving through a height of 20 meters. Ladies and gentlemen, we are using the work energy theorem, okay? The work energy theorem. I've just explained to you that on the formula sheet, you're given these formulas, ladies and gentlemen. Let me just check exactly where that formula is. This is the chapter that we're dealing with, work, energy, and power. Okay, so ladies and gentlemen, we know work is equals to force delta X or delta Y, depending on whether the object is moving up and down or sideways, and then cos 0. And this is the formula that we're using. Work net is equals to a change in kinetic energy. And this is the formula for calculating the kinetic energy. Let me just write all of those formulas, ladies and gentlemen, so that you are able to notice and understand the relationship. So let's not just make this lesson about answering that question. Okay, remember the first formula, we've had it when we're defining the theorem, which is work net is equals to delta K. Okay, and again we notice there's this formula which says work is equals to force multiplied by, because this object is moving up and down, ladies and gentlemen, let's use a delta Y. If it was moving sideways, we would use delta X. Okay, so it's F delta Y times a cos of angle theta. Okay, and the other formula, ladies and gentlemen, is that K, or if you don't want to say K, you can say EK. Okay, I'm not sure how to. Okay, let me just do a forward slash and EK. It refers to the same thing, which is kinetic energy. It's equals to half mv squared. You obviously know this formula from I think, what is it, grade 10. Okay, so ladies and gentlemen, I just want to try and solve this question while having all of these formulas so that you understand the relationship. And again, I'm going to quickly explain a lot with regards to those formulas. So ladies and gentlemen, this is where I got those formulas. They're given on your formula sheet. You just choose the relevant formula. Okay, so ladies and gentlemen, let's now write our formula, which is the work net. Remember, they said use the work energy theorem. Okay, so this is work, this is energy, combined is the work energy theorem. Okay, so that's why we equate energy, the work and the energy. So this K, ladies and gentlemen, it's another type of energy, which is kinetic energy. It refers to objects moving at a particular speed. Okay, we also have potential energy, which are the objects which gain energy as they gain some height. Okay, so ladies and gentlemen, we've got work net, which is equals to delta K. Okay, so what is the work net, ladies and gentlemen? The work net is the work done by the tension plus the work as a result of gravity plus the work as a result of friction, and this is equals to delta K. So what is delta K, ladies and gentlemen? We know the formula for K is half mv squared. So we already have the formula for a K. Then what about this delta, ladies and gentlemen? Delta is change. That's where you say final minus initial of whatever that is the change of or the change in. So in this case, we've got change in kinetic energy. So that means it will be delta of K. So, ladies and gentlemen, that means we have kinetic energy final minus kinetic energy initial. Okay, very, very much important, ladies and gentlemen. What I'm actually doing now is just to formulate using the work energy theorem. Okay, so I assume you fully understand, ladies and gentlemen. So now work as a result of that tension, ladies and gentlemen. So that means we've got a tension. Remember, tension is a force. Okay, tension multiplied by delta y. Okay, before I continue with that, ladies and gentlemen, remember work is equals to force times, let me just say, a distance, and this is measured in joules. Okay, very, very much important. So that means this is a force in Newton. It should be multiplied by a distance which should be in meters. Okay, so that's why here we've got a force multiplied by delta y, which is the distance multiplied by cos angle, multiplied by cos angle. So ladies and gentlemen, it's this formula. So now I'm just expanding each of these by that. Okay, so that's why I'm saying T, which is force as a result of tension, it's that one, ladies and gentlemen. So even if you say force multiplied by delta y cos that, as long as you know that force is your tension. Otherwise you can still say Ft, but otherwise you can just say T. Okay, so now you add with the force of the work as a result of force of gravity. So that means this is the work as a result of tension, this will be the work as a result of a frictional force, and a gravitational force, but this is the work as a result of frictional force, and the whole of this is net because it's total, which is equated to K final minus K initial. So now we are there, ladies and gentlemen. We know mg is the force as a result of gravitational acceleration. Okay, so it becomes mg multiplied by delta y. So remember guys, mg is just a force. Okay, that's why we multiply this mg by delta y. So it's more like it's force of gravity being multiplied by delta y, then it makes it work as a result of gravity, as a result of gravity. Okay, very, very much important, ladies and gentlemen, that you understand where these formulas are coming from, because one thing for sure I've realized, most of learners, they actually get confused by these formulas. Not that they are not able to see what forces are acting on that particular object. Okay, then we can now multiply by cos angle. Okay, plus, ladies and gentlemen, work as a result of friction, which is equated to change in K. Let me say change in K, which is all of that. I'm going to quickly explain a little bit more about change in K. Okay, so ladies and gentlemen, remember delta K, that means it's half mv squared. This will be v initial, v final, then you subtract half mv initial squared. Okay, so that means, ladies and gentlemen, the whole of this, it's supposed to be equated to that, but because I haven't got enough space there, I'll just say delta K, and I will expand that delta K here because I want to explain something. Remember, ladies and gentlemen, we know the mass is 80 kg. Okay, so can we just substitute 80 kg there, ladies and gentlemen? Let's say this is 80 kg. Okay, 80 kg. So now we just substituted the value for the mass. You will understand towards the end exactly what I'm trying to explain to you guys. So that means we now need the value of velocity, and they said it's traveling at a constant speed of 4 meters per second. Okay, so guys, this is where you need this information of constant speed in capital letters. What does it mean, or how is it going to help you, ladies and gentlemen? You won't need to worry about what's your final velocity, what's your initial velocity. You know you've got half into, we know mass is 80, then v final is 4, you square, and then this is half into 80. What is your v initial? It's 4 squared. Okay, very, very much important, ladies and gentlemen. I'm giving you as a quick task, ladies and gentlemen. Please punch all of this, minus all of this, and tell me what answer you get. Okay, obviously I know this is half of 80, which is 40, multiplied by 4 squared. It should be something like 16. Then you know it's like 40 times 16, you subtract 40 times 16. Okay, so ladies and gentlemen, you can see both of these are the same. So this minus that will obviously be equals to 0. Okay, I hope, ladies and gentlemen, you are able to notice where I'm heading with this. Okay, so that means all of these can now be equated to 0. Okay, why can all of this be equated to 0? It's because the speed is constant. But if the speed wasn't constant, ladies and gentlemen, then it means there you're going to substitute the final velocity, whatever that it is, and there you're going to substitute the initial velocity, which is different value from the final velocity, and you're going to get a value which is not 0. Okay, on the right side of the equation, or on the right side of the equal sign. Okay, so ladies and gentlemen, so now please do allow me to equate the whole of this to 0, because you've seen why it can be equated to 0. So that means delta K is equals to 0. Why is it equals to 0? It's because the speed of 4 meters per second is constant. Okay, that's what makes it to be 0 there. Okay, ladies and gentlemen, also please do make sure that you fully understand the meaning of delta and what it does to the formula. Okay, do not just say because you can see it's a K, then you just say it's half mv squared, then you substitute it there, because you're going to have 80 times that 16, it gives you a number there, then you work it out with the whole of this and it leads you in the wrong directions. Okay, so now can we just quickly work out the left side of the equal sign? So ladies and gentlemen, we know the tension is 960. Okay, multiplied by, we know the distance is 20 meters. Okay, then cos of the angle. Ladies and gentlemen, very much important. This is the part that I want to explain. Okay, remember guys, this is that free body diagram. Okay, so the force as a result of the tension, it's in that upward direction. Okay, let me just quickly explain this in a red marking pen so that it doesn't confuse you, ladies and gentlemen. So what I'm trying to explain is that the tension is pulling this soldier in the upward direction. Okay, so that means the angle is equals to 0 degrees because it's in the same direction in which the soldier is moving. Okay, but when it comes to anything in the opposite direction, it becomes a different story, ladies and gentlemen. For example, we know we have got force of gravity in that opposite direction. Okay, it's in the opposite direction, not in the opposite direction but at an angle, because there are no sideways motion. Everything is happening vertically upwards. Okay, very much important, ladies and gentlemen. So that means that angle is now 180 degrees. 180 degrees. Which angle? The angle as a result of force of gravity. Okay, so ladies and gentlemen, let me also try to explain it in a different way. I hope it will then make sense. Let's say you've got a car which is moving horizontally in that direction. Okay, so let's actually say these are two cars and the other one is towing one car, and there's that cable which makes a tension there. Okay, so ladies and gentlemen, what I'm trying to say is these cars are moving in that direction or eastwards, right? So that means the force as a result of the tension or any force in that direction, its angle is 0 degrees. Okay, why? Because it's in the same direction in which the force is being applied. Okay, so that means force applied in that direction, then it's cos of 0. So anything opposing the applied force, it's obviously acting in that opposite direction. Okay, so that means you've got a straight line like that, and you've got two forces. That's obviously if you draw a free body diagram. So that force as a result of a tension or applied force, the angle is cos 0. Now that you've got the opposite force in the opposite direction, then it forms that angle of 180 degrees. So that means a force of friction will be cos of 180 degrees. Okay, so ladies and gentlemen, I'm not really sure if that helped, but I hope to some of you guys it helped, because in case if your teacher is trying to teach you how to answer these questions and teaching you in terms of the angles, you will be able to fully understand what they mean. Okay, so obviously that means there we've got cos of 0 degrees. Okay, then you add, what is m? They've just told us the m is 80 kg. Obviously we know this is 9.8. This is the acceleration and the gravitational acceleration of course, and the distance is 20 meters. Okay, and cos of 180 degrees. Very much important, ladies and gentlemen. Plus work as a result of friction, and this is equated to 0. Okay, so ladies and gentlemen, this is exactly what we are calculating. Okay, very much important, guys. So now you can just punch all of these and add it to all of this. Okay, but let's do it in parts such that we punch this and then we punch that. So that means you've got 960 multiplied by 20 multiplied by cos of angle 0, then we get 19,200, and it's a positive value. Okay, then let's punch all of this. Ladies and gentlemen, before I forget, very much important that at all times your calculator is in degrees. Okay, if it's in, what is it grad or red or whatever, as long as it's not in degrees, you might be getting some incorrect values, especially when you're going to write a geography paper 2, which is map work, mathematics paper 2 in particular, and again also in paper 1, where you might need to calculate some angles where necessary. You will need your calculator to be in degrees, and again in physical sciences, always make sure your calculator is in degrees. Then let's punch all of this. It's 80. I'm sure some of you are done already. Into 9.8 into 20, then cos of 180 degrees. Then I'm getting a negative value, which is negative 15,680. Obviously, this is added to work as a result of friction, and it's equated to 0. So, ladies and gentlemen, what I wanted you to notice, what I wanted you to notice is that negative sign over there. Okay, so guys, some of us, we might not use this cos, that cos as part of our formula. That cos over there, that cos over there, we might not use it as part of our formula. Why? Because we know that cos actually have impact on the direction in which the force is acting on an object. Okay, let me just write here in a black marking pen. I'll just erase what I'm about to write now. So, ladies and gentlemen, because we know work net is equals to that, we know work as a result of tension, it's acting upwards. Okay, and we've got two forces which are acting in the opposite direction, which is minus work as a result of gravitational force minus work as a result of frictional force. All of this is equated to 0. Obviously, you've seen why this is equated to 0 is because of constant speed. Okay, so ladies and gentlemen, I've already indicated the signs over there, that this is going upwards, this is coming downwards. That's if I've assumed upwards to be positive, downwards to be negative, which makes it easy that way. Okay, so the cos angle there, it has got not that much impact, but just to give the direction. Okay, so that means if you punch on a calculator cos 1, cos 0, you might find that it's positive 1. So that positive 1 is multiplied by that t, and 180 just gives you 19,200. If you punch cos 180, you might find that it gives you negative 1. That negative 1 is multiplied by all of this. Okay, it doesn't really make any difference other than the having an impact on the sign. Okay, very much important, ladies and gentlemen. So now let's check. In this case, it means over there it actually should be a negative. Okay, but because we said net, and net means total means add. Okay, that means our final answer for this must be a negative value in joules. Okay, which indicates that work as a result of friction is actually acting downwards. Okay, so it serves as a hint in terms of guiding us if we are heading towards the right direction or not. So that means if we get a positive answer, then something is wrong. Okay, so ladies and gentlemen, what you do now is just to say 19,200 minus 15,680. I'm sure some of you have calculated and you're done already. So it's 19,200 minus 15,680. You get 3,520. So that means we have 3,520 then plus work F, which is equals to 0. So that means work as a result of friction is equals to, you just move all of this to the other side and it becomes negative 3,520. Remember, this is work and it's measured in joules. Okay, ladies and gentlemen, it's very much important that you fully understand this last part, because it's not really just a matter of answering this question, but instead to show you the tricks and how to formulate, and again how to substitute, and what other quantities mean. Okay, so ladies and gentlemen, they're just going to give you a mark for writing the correct formula. Okay, very, very much important, ladies and gentlemen. For correct substitution, they must give you a mark. Okay, and most importantly, ladies and gentlemen, on the right side of the of the equal sign, they also give you a mark. Okay, guys, I'm going to give you a mark for just writing your final answer with the correct SI unit. Okay, so this is how you score your 5 marks. Ladies and gentlemen, I hope you enjoyed this lesson as much as I did. If you have watched this video until this far, ladies and gentlemen, please make sure to like this video, because it serves as a hint or as a guide to me that I'm not in any way confusing you, and again, you appreciate the information that I provide to you guys. So ladies and gentlemen, thanks very much for joining. My name is Desmond and I'm out.